let's get started. We're going to learn about inverse trig. There's a difference between the reciprocal functions and inverse trig. Inverse trig is when we're trying to find the angles, and to do that, we use the inverse trig in our calculators. Always make sure your calculator's in radians, so degrees. So degree, radians, GRD, we're always using degrees. So I'm gonna put equal. So the inverse is those little -1. So the sine to the -1, cosine tangent, you'll do second, and then let's say for sine, and you'll see the sine -1. So you're gonna be using that button to solve for each one of these. SOHCAHTOA, very good to memorize. All you need to know, sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So before we were solving for missing sides, for this lesson we're going to solve for angles. So let's look at example 1. Here it says we have a triangle. We have this theta, that's what the symbol is. It's the angle. So it's a circle with a line between it or across it. So now we're going to go ahead and find what that angle is. They don't give us all three sides. You could do Pythagorean theorem and solve for the last side, but you don't really have to. You need at least two sides to solve for an angle. So now we have to find what each of these are in relation to the angle. So for 15, what is 15 in relation to theta, or the angle? If you remember, anytime you have a 90-degree box, anything across from it is always the hypotenuse. Now let's look at 12. What is 12 in relation to theta? It's across from it, so it's considered the opposite. It's not next to it. Now, we have to focus on one of the three trig functions. Which one are we going to use to solve for the theta? We use one trig function out of three that has an opposite and hypotenuse. And if you look up here, that's your sine. So that means to solve for theta, it's the inverse sine, so sine to -1, times opposite over hypotenuse. Opposite would be 12, hypotenuse would be 15. If you do 12 over 15 in your calculator, it's going to give you some decimal. I forgot what the decimal is, 0.80 something. But you'll do the inverse sine of that decimal. So let me just make sure what that is now. 12 over 15, you get 0.8. So inverse sine of 0.8. Now you go ahead and do the second sine, so the inverse sine of 0.8, and you end up with about 66 degrees. They want you to round to the nearest whole number, find theta to the nearest degree. So it's going to give you some decimal, but it's going to be rounded to 66 degrees. I'm sorry, 53 degrees. Looking at the wrong one. 53 degrees. Let's go to the second one. So we have to find theta. So theta is right here. So now we have 37, we have 15. We have to see what those numbers are in relation to theta. So across 30 degrees, that's the box. That's always a hypotenuse. 15, the relationship between 15 and theta, they are adjacent. They're neighbors. It's right next to the angle. So the trig function that has these two is cosine. So to solve for it, it's the inverse cosine to -1, times your adjacent over your hypotenuse. I don't like it that I don't have a decimal. I always put in decimal form before I find the inverse of it. 15 divided by 37, I get about inverse cosine of 0.41. It's going to round. And when you find that, you're going to round it. It's going to be about 66 degrees. So your theta, your degrees for that will be 66. Again, make sure it's the inverse function, not your actual sine function. Example 3. So now we have to find theta. So 16 in relation to theta is opposite. It's the opposite side. 11 is considered adjacent. It's right next to it. And the trig function that has the two is tangent. So that means we'll have tangent, or theta is equal to the inverse tangent of opposite, which is 16 over 11. And we do that, you can put in decimal form, but you'll end up with 55.5 degrees. And all of these are in degrees, but again, you only have to put just the number form in there. So solving for these, you end up with your degree. On the book it says find theta to the nearest tenth of degree. Make sure you guys are actually rounding. I've been putting it down, I've been writing it, saying make sure to round to this place, and a lot of you weren't. Just be careful, listen to instructions, read your instructions. So that would be example 3. Example 4, it's a word problem. I have my beautiful bridge. My little lines here. So I have this bridge here, and it's from one end to the other end. Here it says, find theta 1 and theta 2 to the nearest tenth of a degree. So if we go all the way over here, again, it's in your book. But if we go all the way over here, if I were to draw this triangle out, we have this as, it's not cute. We have theta 1, and this angle here as theta 2. We have a measurement between the bottom base here. That measurement is 17 here. And now this is where a lot of people get confused. They said the height of this bridge is 15 feet. 15 feet is the height from the bottom going straight up to the top. Like for me, I am 5 feet from the floor straight to the top. I'm not 5 feet when I'm slanted forward like this. So a lot of times people refer the 15 to the hypotenuse. It's not the hypotenuse. It's actually considered one of the sides. It's how tall it is going straight upward. So now we have 15, we have 17. We're gonna go ahead and find theta first. We're gonna find this one here. So to find the first theta, we're gonna go ahead and see what trig function we need to use. 17 for theta is the opposite side. 15 is considered adjacent. So that means to find my first theta, I'm gonna use a function that has a 2, and that would be tangent. So the inverse tangent of opposite, which is 17, over adjacent, which is 15. And then you go ahead and put in decimal form, and then you divide. You go ahead and you'll end up with about 48, and it says round to the tenths, so 48.6. That's for the first theta. There's 2 ways to solve for the second one. I'm always looking for shortcuts, but again, if you don't remember these properties, you don't have to. Let's say the first way. The first way is you have a right triangle. You can only use trig functions when you have right triangles. When you have a triangle of any sort, actually, doesn't matter what shape it is. When you have a triangle, all the sum equals 180. So then we have theta 1. Now we have this as 48.6. We have the right angle as always being 90, and now we have a theta 2, but we don't know what that is. We know that when we add all these 3 functions together, they should end up as 180. So then I have those 2. I'm gonna get theta 2 by itself. So 48.6 plus 90, I got 138.6 plus second theta is equal to 180. To get the second theta by itself, I'm gonna subtract both sides by it. Or some of you have the mindset of just subtracting whenever you see these type of things. Good for you. So when you subtract the 2, minus 180, I get about 41.4? I got about 41.4 degrees. If you don't remember that, we can go ahead and use the tangent. So let's say for this shape here, I'm gonna find theta 2 over here. We're gonna make this is actually theta 2. So now we know in relation to 15 and 17, it's gonna change because now it's a new angle. 17 is considered adjacent. 15 is considered the opposite side. And that means the function that we have to use to solve for that is inverse of tangent. That's the only one that has opposite and adjacent. The other 2 has hypotenuse in it. That's why it's easier to point it out. So now it's opposite, which is 15 divided by adjacent side. TOA, opposite over adjacent. So the inverse tangent of 15 over 17, just go ahead and do it in your calculator, and you actually end up with the answer 41.4 degrees. Same answer, 2 different ways. We'll use the different properties, try to make it as simple as possible. Math is very simple if you understand the policies or the rules. If you guys need any more help, make sure to email me down there, ask me any questions. If the picture is never uploading, don't just skip it because that's 10 or 11 points off your test grade. Just ask me and I'll send you a picture and I'll try to get to you as fast as I can. Bye-bye.